give a quick introduction about yourself, and you can tell me like your journey towards generative AI and those kind of activities.
Sure. Yeah, my name is Ian Kwok. I have a background in trajectory analysis and machine learning. Using it to create a trade bot right now, and using that to place trades and orders so that we can trade on trade bot secrets.
Okay, so what all machine learning algorithms you have used in your project or in your day-to-day activities?
Currently, I'm using a recurrent neural network to pull in the data and then use that API call and split that into neurons. And then from the neurons, then I'm actually training and auto-tuning that to actually place orders, and then giving it a score. So based on how it performs, it'll try to optimize and tune for a better score on that. So.
Okay, so when you say like you are building a neural network, so what kind of technical stack you work here?
You talking about a technical stack?
Mm-hmm.
Currently, I'm actually programming it from scratch, so I'm not using any of the TensorFlow or PyTorch. I'm actually programming it from scratch.
Okay, so let me ask a couple of questions in neural network.
Mhm.
So we do have something like vanishing gradient problem, right?
Yes.
What
Yeah.
is
So
vanishing gradient and
the vanishing gradient is when you have to back propagate, and as you back propagate, you kind of multiply more and more numbers to kind of get the I guess the tuned or learned weights. But as you propagate back over time, you're doing multiplying many small numbers that eventually is just it's just small numbers multiplied by another small number becomes a really small number, and eventually it just kind of goes away. So you can't keep multiplying back too far in time. Eventually it just becomes zero. So that's the vanishing gradient there.
okay? So in your RNN architecture, problem, vanishing gradient problem.
Mm-hmm. Yeah. So what instead of the approach of back propagating, I brought over a technique called auto tuning, which would then go in and basically we call it making mistakes by trying different weights and then forward propagating the simulation. And then if it works out, then based on the score, we'll keep good results and then scrap and throw out bad results. So that way we can propagate forward in time by testing different scenarios and expanding to many different scenarios through back tests in my trading algorithm, so that we can see which one performed better. So we basically eliminate back propagation and gradient descent.
Okay, okay. So you are saying like you are using something like backward tuning. Can you just come again? What was that actually?
It's called it's called Vector BT Pro, where you can actually simulate actual trading data. And so if I perturb a weight here and there and then simulate it and see, did it perform, did it place an order, did it trade, and then if it does trade, give it a point. If it does close the order, give it another point. If it has closed the trade in profit, give it a multiple. And then based on how I forward propagate that, I could run hundreds of thousands of scenarios with different perturbations of each weight, and then propagate it forward and see, hey, which one did best. If it did good, we'll pick that one out and kind of like and use that one, and then propagate another scenario and keep going forward. I kind of call it kind of like daydreaming or evolution, if you want to call it. I'm making mistakes. This one survived, that one didn't. This one did the best. Well, let's take the best runner and forward propagate again. We're just basically making mistakes instead of trying to solve through gradient descent because of the vanishing gradient problem.
Okay, when you say when you work with RNN, it's kind of a plain RNN or it's kind of an LSTM architecture you are working with?
It's basically an RNN that's just it loops back to itself for a recurrent neural network.
Okay, okay. So you are building an RNN from the scratch. So it's with a plain Python or how it is? It's going to be in other programming language or it's in plain Python?
Yeah, it's developed in plain Python. So I basically created a class for, in the sense of, I call it a smart neuron. So in that class, it'll manage its own synapses, the connections between neurons. And if there's multiple connections, it'll know which connection has propagated and fired. If it hasn't propagated and fired, it'll know what is left. So the order of operations is maintained within that class. And also it'll initialize itself. It also has features of subneurons. It also has a basic methodology of, how y equals mx plus b to calculate the weights. But I want to expand that to a smarter neuron where you can use Fourier series and also Laplace transforms, because those describe waves. And that's a little more realistic, I think, in terms of large language models for voice, because voice is all waves. So we can translate that instead of linear y equals mx plus b, translate into frequencies and have its real and real and unreal imaginary numbers is what I was trying to get, of different frequencies to describe the actual network instead of using y equals mx plus b. So that's all kind of built into my class right there.
Okay, so how many layers of RNN you have built actually? What is the architecture of your RNN?
Currently, I have one layer right now, but it can expand to multiple layers later on. Currently, I have an input layer, a hidden layer, an output layer, and also like a final output layer, because sometimes the output also has more sub outputs. For example, um, like I guess the tray type would be an output, but then I would get that and then in a sense softmax it to a buy or sell, or a trade type of, fill or kill. Um, do I good till canceled? There's three or four other options that you got to kind of break it down to. So I kind of broke that final output to a deeper output in a sense, and that makes sense.
Okay, so how many layers do you have in that hidden? I mean, hidden layer. How many neurons
uh,
do you have?
I'd say over, I think over 100. I think I last saw was like 900 about 900 neurons. And
Mm-hmm,
I'm also running Dask to
mm-hmm,
parallelize those computations. And my computer is a 32 core, actually a 64 thread, Threadripper Pro. So I'm breaking those processes and parallelizing that into separate CPUs. I thought about using the GPU, but the translation between CPU memory to GPU memory and then using the GPU to run it, it wasn't cost effective. So because of the way recurrent neural networks are working within that, I'm using CPU for now. But because of the smart neurons, later on I could incorporate computer vision into the network, and then when I use computer vision, then you have a fixed context window, and that would make sense to use the GPU as and also input to the recurrent network. So that would be you know something where I could leverage the GPU more effectively.
okay, so what all things you are planning in your mind actually to improve your current model? So what all things is in your upcoming steps?
Uh, right now, the coming steps will be tying it to the API to actually place orders. And then once that's done, I also need to auto tune the weights and the biases. Um, After the weights and biases is done, then I need to send that into a backtest uh, plugin, and then run. Basically, once I have a live neuron that would run, but as it's waiting and running, I'll have, in a sense, a separate scenario where it's constantly backtesting and learning and training. And when it trains and finds good new scenarios, it'll update the main live neuron for live trading. Okay. So in a sense, it's always learning. You don't have to train. You don't have to like train it and then inference it, and then things change. I have to go back and train inferences. It's always gonna inference, but also constantly train through back testing, and then automatically inference over time. So as it's learning new things and it's getting better, it'll inference back to the live branch, and then all these neurons are in a sense, what's it called, reversion control with GitHub. So there's all JSON format of all the neurons I've stored, and then updating that in GitHub so that there's a version control of a database of version histories of what's worked and what's not worked. And I can go back to find the one that has the best score and pull those neurons back in and test it and then and push it back into live. So I can always revert back if I need to and find the best one. So that way, when I run a new, when I start my computer or my computer crashes, I don't lose all my training data and whatnot. It's all backed up into a version controlled history.
Okay. Yeah. Okay. Yeah. Yeah, I think yeah, that's good conversation. Like, yeah. So, like, apart from RNN, have you ever worked in any other projects, any other thing?
Yeah, I mean, as far as like my coursework, where like computer vision and recognizing certain things and patterns, that was pretty interesting. Large language models, I've done some of that with tokenization, on predicting the next token key. Um, what's it called? Fine tuning. The hyperparameters, but you kind of do it manually to try to fix the overfitting, adding dropouts and whatnot to for your data. Of course, like this isn't supervised or unsupervised training right now. Right now, it's supposed to be unsupervised neural network, but the application of what I've learned in my certifications wasn't applicable to this real world type of application because they don't really teach you how to build a trade bot from scratch and whatnot. They teach you the conventional classifications of what's a dog and what's a cat. Well, I don't need that for trading data and computer vision, facial recognition. I don't need that for this. But I can see recognition of patterns, trading patterns, head and shoulders, or a bull flag, or kind of a different shapes and whatnot that you can recognize, that I can see it being used for computer vision later on. But right now, just kind of building the backbone is where I'm at right now. So eventually, I would incorporate everything or more of other neural network or deep, different networks or different techniques and strategies into the trade bot.
Okay. So, like, in transformer architecture, we do have something like positional encoding, right? So where we encode some odd numbers with sign and even numbers with cost. After the word embedding, we have something like positional encoding, and then comes the attention mechanism.
Oh, like the transformers and stuff.
Yeah, yeah.
Yeah,
So any
yeah.
any thoughts? Mm-hmm.
As far as yeah, I mean, I did do some coursework on the tokenization of that and like fine tuning large language models so that you can use a GPT. I think it's called FLAN-T5 or whatever that is, and then fine tuning that for a specific case like medical or lawyer stuff, so that that the that model will be specific to that application. And because of course there's like daydreaming and forget other things that you trained it on because you're focused on this other subject, um, kind of thing. So you could then fine tune the models without having to rewrite or retrain from scratch, kind of thing. So
Okay, so my thing is like why we need to position encode certain things with sin theta and certain things with cos theta. Any
okay, say
idea
that
over
again.
there?
Repeat your question. It was
Okay,
hard to hear you.
so in the transformer architecture, we do word embedding. That's our first step.
Word embedding. Okay.
Yeah, after that we do have something like positional encoding.
Uh huh.
So in position
Vectorization.
encoding, yeah, so in position encoding, what we will do, we will encode odd numbers with sign and even numbers with cost, and vice
Okay.
versa something. So what is the purpose of doing by that?
Okay. So you're saying you'll encode even numbers with sign and
Mm-hmm.
odd numbers with cosine
Yeah, yeah,
in the positional encoding.
yeah, yeah, correct.
For the large language model.
Yes, in the large language models, yeah.
I think okay, I'm gonna take a guess, but I would say like different numbers sign will be you will usually in Laplace transforms and stuff, they usually have an imaginary axis and then a real axis. And so it gives it more dimensionality to the encoding.
Okay, okay, it's fine. So yeah, when it comes to, I mean, apart from your project, right, in GenAI, what all packages you have explored apart from OpenAI and BARD or something like that? What all things you have
I guess
tried?
pandas, I think a little bit of scikit-learn.
Mm-hmm.
Um right now, and then Dask with parallelization of that.
Mm-hmm.
Um and let's see if there's any other ones I've used here. Here's my settings. Interpreter. Oh, there's a visualization with Manim
Mm-hmm.
package.
Mm-hmm.
Let's see. Did I say Panda? Panda. There's already. Yeah. I think that's pretty much it. It's very to the core. I'm not using any of the PyTorch or whatnot
Mm-hmm.
yet.
Okay.
I don't think I need to get into that yet until I start to use my GPU.
Okay. Okay. Yeah. Yeah. Okay. And I think I'm done from my end. So